Hello everyone, my name is Pawan. I am the OCFP faculty in Orchids International School. Today we are going to discuss about the board examinations preparation strategy. Today I am going to discuss mostly on the concept of physics. Today we are going to discuss about the previous year questions which was asked in the CBSE examination from the chapter the magnetic effects of electric current, and I am going to discuss the questions one by one. So, we are going to discuss the first question from this chapter which is asked in 2024 board examination. You can observe here they asked this question, why the two magnetic fields do not intersect each other. Okay, so that is the first question they asked recently. They do not intersect each other. So, you can observe here the statement. We have to tell the reason why they are not intersecting. As you observe here, if you take a bar magnet, okay, we have seen a north pole and south pole to this bar magnet, right? So, we can know that the magnetic field will emerge from north pole and it will converge at south pole. So, this is what the magnetic field will be there around the bar magnet. We know this region, and they will emerge at north pole and they will converge at south pole. So, if they if as you seen here, they are going in a parallel lines, nowhere the lines were intersecting. So, if you observe any magnetic lines were intersected in this way, you can observe here at one point it is indicating the two directions of the magnetic field, which is practically impossible. So, that is the reason we are telling, we can write here the magnetic field will be in one direction itself, there will be no two directions. So, that is why we cannot write, we cannot intersect the magnetic field each other. So, you can write this reason here. So, when you come to the next question, so what happens to the uniform magnetic field? How is the uniform magnetic field is in the given region is represented? They asked us to draw a diagram here. As we know here, all the magnetic lines will be in parallel. Just now I explained you around the bar magnet. So, if you take a bar magnet, all will be in this region. They are emerging at north pole and they are converging at south pole. So, if you observe this part, they were drawing in a parallel line. So, uniform magnetic field will be placed in this distance, which is going from north pole and converging at south pole. So, the next question which I am going to discuss is, it is also from the 2024 board examination, as MCQ they asked this. So, the strength of the magnetic field produced by a current carrying solenoid. First of all, I am to explain you about the solenoid. What is the meaning of this solenoid? So, solenoid is a number of coils. Okay, it's like a number of copper coil with so many wounds, okay, which is placed here, and it is about to pass the electricity. It will generate a magnetic field around it. So, that part we call it as a solenoid, and they were asking us on which parameter it is does not dependent. It is not about dependence. Here the students can make a mistake without understanding the question properly. So, please see the question, that the factors which does not depend they were asking. So, when there is more number of turns, we will indicate the number of turns by n, and the current flowing by I, and the radius of solenoid is r, and the material of the core is the different type of the metal which we are using. So, when you see this four options, we have to observe each one and we have to verify the answer correctly. So, first one, when there are more number of turns, yeah, it is compulsory dependent, because more number of turns will give you more number of more magnetic field, and the more current, then it is also dependent. More current, obviously it will give you the more magnetic field. When you come to the third option, the radius does not depends on the strength of the magnetic field. So, the fourth option, again the material of the core. So, it means solenoid which material, for example, if you are taking copper, if you are taking a more good conductor, then the strength of the magnetic field will be more here. So, option A and option B and option D are related to the strength of the magnetic field. So, the only option which is left out is the radius of the solenoid, which does not depend on the strength of the magnetic field. So, third question is the assertion-reason type question. This is also asked in the recent years. So, we will go through two statements one by one. Okay. So, assertion-reason question. The assertion is the deflection of the compass needle placed near current carrying conductor wire decreases when the magnetic field of the electric current, when the wire is increased. So here they were given here, when the deflection of the compass needle, we know that when there is a, we know that when there is a current carrying capacitor, okay, for example, if you observe here, when the current is flowing through this, a magnetic field will be created around this. So more the current, the more the magnetic field, so the deflection will be more here. So but here they were asking here, the compass needle is of a current carrying wire decreases when the magnetic field is increased, which is, the statement is wrong. Actually both are directly proportional, but here they are given in the statement as inversely proportional. So which is, the first statement is wrong. Now come to the reason. The strength of the magnetic field at a point due to the current carrying conductor increases on increasing the current. Yeah, this is correct, because more current will flow, then more magnetic field. So that is, second point is correct, the reason is correct, but the assertion is false. So when you go through these four options which is given here, A option both are true, which is wrong. B option again they mentioned both are true, but there is no correct explanation, even this is wrong. Now if you observe here, A is true, but according to the conclusion which we made, the A is false. So even C option is wrong. So which option is correct? So option D is only the matching, A is false and R is true. So that is what the third question of the assertion reason questions. Okay. So now we'll go to the next question. So next question is, they were, this time they asked about the diagram. So we know that, here the, you have to show the pattern of magnetic field on a horizontal sheet of paper due to the straight conductor. So that means, if you see this diagram here, so this is a circuit which is passing the electricity, and we can see here the copper conductor, that is copper wire, which is a current flowing conductor which is connected here. And when the current is passed through this, here I want to explain you about one more rule, that is known as the thumb rule, which is given by right hand thumb rule. So we have to take our right hand, okay, we can place our thumb in this direction, so which current is flowing. So if you observe this circuit, the current is flowing in this, the current is flowing in downward direction. So we have to keep this, the thumb will indicate the current flowing direction, so we have to keep this thumb down, and you can whirl this, okay, you can twirl this. So the fingers which are twirling will indicate the magnetic field around this. So you can observe here, the current is flowing down and the magnetic field is going in a clockwise direction. You can observe here, the clockwise direction is observing here. So that is what the diagram they were asking here. So the direction of the current flow we have to indicate, yes, that we have done. And the next one is the corresponding magnetic field around this. So when the current is flowing down, just now I explained you the right hand thumb rule, we have to do it. So the right hand thumb rule indicates that when the thumb is placed in the direction of the current, the fingers whirling will give you the magnetic field. So this is what the next question, and they were asking the statement of the right hand thumb rule. Okay. So this question was asked in the 2 years, that is 2024 and 2023. So it is very important question. So children should not make any mistake in this. Okay. Now we will go to the next question. So next question for us is, name the device used to magnetize a piece of magnetic material. So generally we know, when a current is passing through this, around this magnetic field will be created, right or not? So in the same way, if you pass the current through this any solenoid, just now explained, a solenoid is a copper windings which has multiple turnings around it. So when I connected this copper windings, current carrying solenoid, copper windings, number of turnings to the circuit, and the current will start flowing. Inside this solenoid, we have to keep a soft iron. Remember this point, we have to keep a soft iron. We cannot keep a normal steel, metal or anything, because soft iron will carry the magnetic field in one direction. Okay, it will lose once you take it out. So the magnetic field around this will generate, and it will create a permanent magnet or current carrying solenoid. Okay. So this is the diagram they asked for this. So this is the next question. This is also they asked in the 2024 examination. I hope this is clear for you. Next question we will move it. So next question is, they asked here a diagrammatic question. You can see here they have given us a ABCD current carrying loop. So and they indicated the current flow in each of this. So the current is flowing in a clockwise direction. If you observe here, it is going in a clockwise direction, A to B, B to C and C to D and D to A. So in the clockwise movement of the current, and they were asking here, there is a conductor XY. They bought a conductor. For example, let's take this is a copper wire. They have bought this conductor near to the loop. Okay, so it is also such that the side of the AB side is parallel to the plane of the loop. Okay, and they were asking here, if the steady current is established in the conductor as shown, now first option, will the conductor will remain stationary at same place? Second option, move towards AB. Third option, move away from the AB. Fourth option, rotate about its axis. Now how we will decide this? We know that when the current is passing through this, the closed coil, okay, we know that there is a magnetic field which is generated here, right or not? And another one, another current carrying conductor is also present, and again the magnetic field will be generated around this. So when you observe these two, there is a force of attraction between them due to the magnetic field which is generated. So which will be the correct option? The correct option will be the B. So which is the AB conductor will move towards the loop. Okay, this is what the next question they asked as MCQ. Okay, so now we'll go to the next question. Next question is again assertion reason question. So they asked here, magnetic field of lines will never intersect each other, and reason they gave. If they intersect at the point of intersection, we will have a compass needle showing two directions. Is it true or not? This one I already explained you. So when you take any magnet, okay, so the lines will not intersect. If they intersect at this point of intersection, we have two directions of magnetic field, which is impossible. So this option reason is correct as well as assertion is correct. So both are correct explanation. So what will be the answer? So option A will be the answer. I hope this is clear for you. Okay. Now we will go to the next question. So question number 8 is, they have given here a uniform magnetic field flowing in one direction. You can observe here, and they indicated two. They indicated here two, one electron and one positron, two particles. We know that the electron is moving in downward direction from the diagram, and the proton is moving in the upward direction. So we know that the resistance to the flow of electrons is current. So when electrons are flowing in this direction, current will flow in which direction? Opposite direction, right or not? So when the current is flowing in upward direction, opposite direction, so here we have to use Fleming's left hand rule. So here you have to use Fleming's left hand rule. So whenever you are using this Fleming's left hand rule, we have to understand that, so we have to take our hand and you have to keep it, take your left hand and you have to place them perpendicularly, three lines. So I will show you the diagram now, so which will be more clarified for you. So you can see this diagram. So we have to place the three fingers, okay, so that the forefinger which is present here will indicate a magnetic field, okay, and the middle finger which is placing it down will indicate a current, and the thumb which is coming up will indicate a force. Okay, so this concept is used to indicate the direction of the force which is taking. So in the given direction, in the given question, they were asking us here about four options. So both pointing in the plane of the paper, okay, the electron and positron experiences forces in which direction they were asking. So how this electron will create a force and how this proton will create a force in this field they were asking. So now we will go to the through four options. So both are pointing into the paper, both are pointing out of the paper, and one is pointing out, one is pointing outside, inside. Okay, so we will verify that. So we know that electron is flowing in this direction, means current will flow which direction? Opposite direction. So as usual, the protons are flowing in this direction, means current is also flowing in the same direction. So we will indicate, so this is the current here, okay. So we will indicate the current here. So this is the direction of current. So this is the current. So we will place this thumb to this direction, okay. So this is the current which I placed here. So the current is moving up, right. So we are putting this to this, or else we are placing this magnetic field towards this, okay. So the magnetic field is placing towards this side, okay. But if you understand this, magnetic field is going through this direction, electricity is going, current is flowing to this direction. What about the force here? The force is going inside the plane. So the what about the electron force? Electron force is inside the plane. Now when you come to the protons will also flow in the direction of current. So even the protons will also flow inside the force will be inside the uh, magnetic field. So which option will be the correct here? So both are pointing into the plane of the paper. So both are pointing into the plane. You can observe here. So we have used which rule here? We have used here the right left hand thumb rule, that is left hand Fleming's rule. So we have to indicate these directions by using left hand Fleming rule. I hope this question is clear for you. Let's go to this next question. So next question is, here they given here again MCQ type of question. The pattern of magnetic field produced inside a solenoid. Just now explained to solenoid is a multiple copper turnings which are connected to electric circuit. So the solenoid will behave as a current carrying conductor. This is what solenoid means. See here, there are multiple turnings. So when the current is passed, the magnetic field will create here. So the magnetic field will be created here. So this is what the solenoid, and it will behave as a bar magnet. So the solenoid will behave as a bar magnet, just like at north pole the magnetic lines will emerge and they will converge at south pole. In the same way, see here, this is what solenoid. Solenoid is a coil of many circular turns of insulated copper wires, so that the magnetic field will generated around this. Okay. Now come to our question, what is happening. So this question they asked us, yeah, the current carrying conductor, a device which produces magnetic field similar to the bar magnet, it is nothing but a solenoid. So option C is the correct answer. Now we will go to the next question. Next question is again assertion-reason question. The magnetic field is around a current carrying straight wire. Do not intersect each other. The magnetic field of a the magnitude of magnetic field produced at a given point increases with increases in current. Yes. So when you observe here, both are correct, but are they related each other? No, because the magnitude of magnetic field produces with current, but here current carrying conductor do not intersect each other, because both are statements are correct, but both are not related to each other. So which option will be the correct? First option is both are true and reason is correct explanation. Second one is both are true but reason is not correct explanation. Both are irrelevant. I hope you got this. Okay. Now we will go to the next question. So the next question is again they asked here the similar kind of question which we have seen before. So here they mentioned here the magnetic field, and again they mentioned alpha particle. So now they given 4 options here. So now they are asking alpha particle enters the uniform magnetic field, okay, and the direction of force experienced by an alpha particle they are asking. Here also again we have to use same left hand thumb Fleming's rule. So take your left hand again. So this is the magnetic field, this is the current, this is the direction of force experiencing. So now we will see where is the magnetic field here, which direction is going, it is going in this direction, right. So now what about the alpha particle? Alpha particle is going down, the force will be out of the page. So for example, the magnetic field is aligned like this and the current is moving down and the direction is coming out of this. So which option is correct here? So option D is correct. The alpha particle will experience force in outward direction. Okay. Now go to the next question. Next question is here they asked the diagrammatic question again. They asked here draw the diagram of magnetic field of lines of a current carrying solenoid and a bar magnet. So here they were asking we have to compare these two, and the third question is about how both are similar and how both are there are any dissimilarities. The first one is the solenoid, we know there are multiple copper turnings which is rounded here, and when you pass current it will generate a magnetic field. So the magnetic lines will emerge here and they will converge here. Similar to the bar magnet, see here, even here in the bar magnet the magnetic lines will emerge at north pole and they will converge at south pole. So are these two are similar to each other? Yes, they are similar to each other if you observe carefully. So this is also producing magnetic field around this, even this is also producing magnetic field around this. So these are the two diagrams first they were asked us to draw, and the third question is they asked is we have to distinguish, we have to differentiate them between a solenoid magnetic field and a bar magnetic field. So we will see the differences here. They asked here A solenoid is an electromagnet. Why it is electromagnet? Because it is created due to the magnetic field. The solenoid is created due to the magnetic field which is caused by the current. So that's why it is electromagnet. It is not a natural magnet. But when you come to the bar magnet is a natural permanent magnet which is not created due to the electricity. It is created generally by its properties, its natural property. So that is the first dissimilarities we can do it. That is, a solenoid is electromagnet, but a bar magnet is a permanent magnet. Now when you come to the next one, the strength of the solenoid, for example, the strength of the solenoid, this is a solenoid, more current you pass, more magnetic field will generate. But is there any current we are passing here? No, we are not passing any current here. So here we will not depend on the intensity of the current, but here we will depends on the intensity of the current. More number of turns, more field, more current, more magnetic field, and one more, it is the material which you are taking. For example, copper conductor you have taken, copper turnings, then it will be much more magnetic field. So that is what the next dissimilarity is. The strength of the magnetic field of solenoid depends on number of turns, current which is passed through this. But bar magnet, it is just a strength of the magnet, it is a natural property. So this is what the dissimilarities you have to write in board examinations when they ask this type of questions, which are very very important, the solenoid and the bar magnet. Okay. Now we will go to the next question. Now if you come to the next question, here they gave us 3 diagrams again. Understand the diagrams carefully and we can answer one by one. Now you can see here, given below are the 3 diagrams of showing entry of electron. Electron is entering perpendicularly here. Okay, electron is entering in inclined position here. Electron is entering in parallel to the direction of the field here. Now they are asking here, identify the case which the force will be maximum, here or here or here. When you observe here, when the magnetic field is going in this direction, okay, place the again thumb rule here. You can observe here, magnetic field is going on here, electron is going here. So the force which is perpendicular to this will be always maximum. When the electron is travelling perpendicular to the field, we will have maximum magnitude of force. So in these 3 options, which option is having maximum? That is first option. First option is having the maximum amount of force. Now when you come to the second option, the force will little bit decrease because it is getting inclined. When you come to the last option, it is going parallel. So the force exerted is very very least in this. So they asked here 2 conditions, where it is maximum, where it is minimum. So first option, force exerted on the maximum in first case. Why? Because it is going perpendicular to the field. And the minimum in the third case. Why? Because it is going parallel to the magnetic field. Okay. I hope this is clear for you, and next we will go to the next question. Again here they asked for 4 marks question. Okay. And even this is a direct question which we are studying about the basics of magnetism. Let us take a bar magnet. They were asked here, a student fixes a sheet of white paper, he has taken white paper and fixed adhesive materials, and she kept a bar magnet on the paper at center and he sprinkled some iron fillings around this uniformly. And what he observed, that they were asking, draw a diagram, okay, to show this pattern of iron fillings. After some time, the iron fillings are getting arranged by themselves. So they were asking us to draw this pattern. Next one, what does the pattern of iron fillings demonstrate? And third question, how is the direction of magnetic field at the point determined by using the field choosing lines? Now one by one we will see. First question, as you seen here, when you place bar magnet on the piece of paper, you sprinkle some iron fillings, you can observe that the magnetic lines will emerge from north pole, they will converge from south pole. So this is the first diagram they asked about to draw. Now come to the next question, what does this pattern iron fillings demonstrate? Iron fillings are just demonstrating that they were just showing us the magnetic field of lines, that is the power of or intensity of magnetic field around the bar magnet, up to which time it is there and how much field it is there, they were showing, they were aligning by themselves. So the second question answer is, they were indicating us the intensity or the magnetic field lines, right. Now come to the third question, they asked us here, how is the direction of magnetic field at the point is determined by using 2 field lines. When you place any north compass here, the north pole, at the north pole, the south pole of the compass will will indicate to this, and when it's keep on going through this, when you repeat it throughout, it will converge at south pole. So this is how we will do it, and but they were asking here, why do two magnetic field lines do not cross each other? So if you observe here, this one is again repeated from the previous years, which the previous questions which I discussed. So they cannot intersect each other, because once they intersect each other, we will have a two different set of magnetic field of directions, so which is not possible. So that is the answer we have to write for third one. This question they asked for 3 marks. Okay. Now we are going to discuss one more question. This is also the diagrammatic question, you can observe here. Here they gave two diagrams, figure A and figure B. They have asked the questions based on these two diagrams. Now we will see one by one. So first question they asked is here, in the first diagram they mentioned P and Q, and second diagram they mentioned R and S, and they were asking us name the poles P, Q, R, S of the magnet in the following figures A and B. If you observe here, P, Q is just indicating the magnetic field of lines. So we know that at P is the north pole the magnetic field is emerging, and Q is the south pole, magnetic field is converging. So that is what the first diagram. So we can know that P is P and Q are north pole and south pole of the magnet. That's it. Now come to the second figure. Second figure they asked is here R and S. If you observe here, this is different figure and this is different figure. This is north pole and this is south pole of other magnet. So once you see here, R and S also indicates north and south pole, then the magnetic field is created. Here there is a single magnet, but here there are two magnets here, one here and one here. In between those two there is magnetic field. Do not confuse here. So just observe the diagrams carefully. These questions, this concept of questions might repeat in your board examinations. Now come to the last next B part of this question. State the inference drawn about the direction of the magnetic lines on the basis of diagrams. So if you observe here, if you see here, wherever it is in first diagram or second diagram, both of them are closed loops and parallel loops. Okay, so this is the inference and conclusion we can give from this. Both the magnetic fields, when it is single magnet or when it is double magnet, the magnetic field which is created around this are parallel and closed loops which are parallel and closing at south pole. Okay, so I hope these questions were clear for you. It will help you for the preparation of board examination. So today in this video I am going to discuss about the strategy to attempt the CBSE examination of physics subject mainly. Okay, so now I am going to discuss about the important topics and the strategy what you have to be followed while preparing for the CBSE examination. So let's go through the first thing. Units of physics in our science CBSE grade 10 textbook are natural phenomena and effects of current. So if you observe here, in this natural phenomena we have two parts. The first one is reflection and diffraction of light, and the next one is the human eye and the colorful world. Okay, and the next one is the effects of current. We have electricity and we have magnetic effects of electric current. So both of the chapters are having the almost the equal weightage, like 12 marks from the natural phenomena on an average, and 13 marks from the effects of electric current. Now if you come to the next unit distribution, okay, unit weightage, around 52% and 48%. So both are very important. You cannot skip anything. So both are of having equal weightage. Natural phenomena is of and effects of electric current. Both you have to prepare in equal terms. Now I am going to discuss in detail of each chapter what is going to be important and what you have to be concentrating more. Okay. So whenever you are preparing for the physics examination of CBSE board, so we have to distinguish between the 3 points. One is numerical ability, next one is diagrammatic questions, and you have to draw the diagrams, and the next one is conceptual questions. So now first I am going to discuss about the numerical type of questions which might be coming in the physics from the both of the chapters and the topics. Okay. So now when you go through this the concepts, first thing, the most important numerical will be coming mainly from the Ohm's law. We know that V is equal to IR. So from that they can ask you some type of numerical questions. So prepare the Ohm's law first, then next resistance formula, we know that already, rho L by A, and the combination of resistance, whether they were in series or whether they are in parallel. Even this we have every year there is a combination of resistance questions will be there. When they are in series, the sum will be taken R1 plus R2, and then they are in parallel, we have to use the formula of 1 by R is equal to 1 by R1 plus 1 by R2. So those type of questions are repeating regularly. So concentrate mainly on this resistance concept. Okay, after that come to the heating effects of electric current, next electric power. So these topics from the electricity are very very important. So never ever skip numericals on these topics. Okay, now come to the next concept, that is lens and mirror formula. We know that 1 by f equal to 1 by f is 1 by u 1 by v formula, right? So whenever you are applying for lens mirror formula without understanding sign convention, we cannot do. So try to understand the sign convention, then you can do lens and mirror formula questions very easily in the exam. Okay, so there are so many questions in our CBSE textbook. So this is the next important topic after solving the resistance concept. Okay, the next one is the refractive index and the correction of eye defects. Refractive index, before understanding refractive index, we have to understand about the passing of light ray from rarer to denser medium. Okay, and different types of mediums. Okay, you have to understand that. Then correction of eye defects, like here it will include myopia, hypermetropia. Okay, so we can expect majority of the numericals from the these topics in your board examinations. Now I am going to explain the diagrammatic questions from the topics where they can ask you the most number of diagram. Okay, in the physics examination. Mostly whenever you are drawing a diagrammatic question, you should use pencil. This is the first point you should remember, everyone. Okay, so for example they can ask an electric circuit. Here you should be aware of every symbol which you are using. For example, for a key, what symbol you are using; for a plug, what your symbol you are using; for resistance, the symbol should be clarified in your mind. Then use pencil and scale and draw it neatly. Okay, so this is the next step you have to follow. Okay, so the electric circuit and Ohm's law circuit, VI characteristics graph. Okay, the concepts most of the times they have repeated in the board examinations. So concentrate the diagrams from these three. Okay, and next come to our magnetic effects. So magnetic effects based on the bar magnet. Okay, mainly on the solenoid and the straight conductor and closed circular loop. Okay, these two questions were repeated most number of times. Even here, while drawing the magnetic lines, be careful while drawing with the pencil and draw them in a neat curved manner. No need to draw randomly. Okay, so try to maintain the uniformity and neatness while drawing these diagrams with pencil. Okay, only with pencil itself. Now come to the next one, that is the domestic electric circuits, which is there in the same chapter. Here also you have to know the significance of each symbol which you are using. Okay, and one more thing I want to explain to you is whenever you are drawing a ray diagrams. Okay, so for example lens and mirrors, ray diagrams, myopia, hypermetropia, defects of eye. Okay, whenever you are drawing these diagrams, most of the people will make a mistakes in mentioning the arrow mark and some symbols. You have to mention every point in the ray diagram. You should not skip any point. For example, radius of curvature. Okay, center of curvature you have to mention there, as well as the arrow mark from ray which direction to which direction it is traveling. The arrow mark we should not miss, and the focus we should not miss. Whatever concepts or terminologies which are there in the diagram, we should never miss. Everything should be perfectly mentioned. So that is what in the last concept, rainbow formation. Okay, from these topics they might ask most number of diagrams. Okay, for this I recommend you to go through the activities in our CBSE textbook. They might ask the same kind of diagrams. Okay, so this is the second part of our preparation, that is diagrammatic questions. Now the last part and third part is, that is conceptual questions. So from which points or which concepts we have to do the conceptual questions. For example, first one is Ohm's law verification. So from that they can ask conceptual questions. They can twist the question. So be clear with the concept, and then you can apply the concept. Try to solve as many different questions as possible. Okay. Now resistance formula is there itself, rho L by A. So they can change, they can give most number of questions every year on this resistance formula, rho L by A, how the resistance depends on length, how it is depending on area of cross section, how it is depending on the resistivity. So that formula you have to understand and you have to apply that formula. So this was the concept. Okay. Next one is the advantage of AC over DC. Next one is activities of like magnetic field of electric current. For example, here we have to use right hand thumb rule as well as Fleming's left hand rule. So whenever you are applying this rule, be very careful and understand that from which direction to which direction it is traveling, then you can apply these two rules. So these two rules, from every year they might ask one question from these two topics. Okay. Next one is a dispersion of white light in the glass prism. Here it is very important, again the ray diagram. Okay, they can ask you about the ray diagram from the glass prism and glass slab. Okay, this is also one of the most important thing. Last one is atmospheric refraction effects, that is dispersion. Okay, like a twinkling of stars. They can ask you in from these kind of tricky questions. Okay, they can twist the questions. If you are clear with the concept, you can attempt this. So these topics are very important in a conceptual learning. Okay, and the next point which I want to discuss with you is how to attempt this. Like after learning all the concepts, okay, so you have to go through the marking scheme present in our CBSE website. Okay, so you have to go through the marking scheme. For example, for 1 mark question, you have to attempt in a way that the keyword should be perfect, and try to answer the question in one sentence or 1.5 sentence. Okay, so no need to put more effort when the question is for less mark. Okay, and next one is try to attempt the sample paper which was given as a mock test by CBSE. You should analyze your mistakes from that. Okay, you should give it as an exam. Be serious and give it as an exam, so that we can get get to know your mistakes before itself. So you can understand the weak concept and weak points and prepare that again before board exam. That is what the strategy you have to follow this. Okay, and last and final thing, very important, is we have to memorize all the formulas and make a short notebook. Okay, short formula of all physics formulas which is made. Then before exam it is very helpful for revision. Okay, and next point, how to write exam. Just now I mentioned you, depends on the marking scheme, answer this. For example, for the marks allotted or 1 mark for the question, try to attempt in a shortest way as possible, but use the proper keywords. Okay, if it is for 2 marks, try to explain with much more explanation. If it is for 3 marks or 4 marks, whenever diagram is necessary, try to draw a diagram and with pencil and try to explain with the properly in the theoretical way. Okay, if there is a uh, question of in section B, like numerical question and theoretical question, if you are not confident of numerical question, I recommend you to go through the attempt theoretical question. Okay, if you are perfect in the numericals, then only attempt numerical, or else try to attempt theoretical if you are familiar with the concept. Okay, and the last one is, whenever diagram is required, okay, try to explain the answer from the diagram. Okay, so I hope if you follow this strategy and the key points which I explained you can score very good in your board examinations. Thank you, all the best.